4,000, no, 5,000 per worker. Okay. So what we need to do is do some sort of a solver table, right, where we keep changing the firing cost, keep increasing it. And at some point, we don't want to fire anybody anymore, right? So the question is, how much would it cost me, increase the firing cost? I'm going to stop. So I'm going to come back to my model. And what I want to do now is look at where we're at. So hiring and firing, right? So what I could do, I'm going to go over to the side here, right? And say I'm going to come over here under I-21, okay? So this is, what I'm going to do is, notice that here, somewhere along here, right, we had 2 fired and 1 fired. So what we want to do now is I'm going to put, just for marking, I'm going to put equal, and I'm just going to sum all the red cells where we made decisions on firing, right? And so I'm going to sum B21 through G21. I'm going to do a right parentheses there. So therefore the number is 3. So during the life of my entire 6 months, I did fire 3 people. So the real question again is, at what firing cost will that number end up being 0? Right? That's the kind of way of doing it. Because rather than having to look at each cell, why don't we just sum up everything in the cell and say, okay, that's our total you ended up firing over the 6-month period. And remember what the question is again. The question says, at what firing cost would the model suggest to not fire any workers? So not fire at any time. So now, what we're basically saying is we're looking at this. We could name it. I'm not going to worry about it, but that's the cell I'm interested in looking. And we're looking at, but the one that we're going to change is here. The that's a hiring cost. The firing cost. It's currently at 5,000, so clearly that's not enough. So we're going to do a solver table. Let's make it 5 to 15,000. And let's see at what point, whether somewhere between 5 and 15,000, the sum ends up being 0. Okay? The sum ends up being 0. Okay, so we go to solver table. We run the table. We say yes. It's a one-way because we're just replacing what? The input cell is B12. I just collected B12. And then we're going to start. Minimum value is 5,000 because that's our starting. Maximum, let's make it 15,000. And let's increment it by $500. I mean, you can do anything you want, right? If you want to be more precise, but this is just, again, we're trying to ballpark it. And then what is it that we want as output? That number. I put in I-21, the one that just added up all the cells about how many we fired over the 6-month period. Got it? So that's what we're doing. So again, we're replacing the 5,000, which right now at 5,000 firing costs, we did fire a few people. So we're going to continue to increase it from 5,000 to 15,000 for 500 increments. Each time we do that, we run solver, and then we say, give me the number here. Right now it's 3. We fired 3 people over the 6-month period. Let's see what the number is, and let's see when it gets down to 0. So I run it, and there it is, and aha, we can actually even see the graph. And you see, so you can see that at 5,000, we fired 3 people. He went up to 7,000, and you drop. So we got down to here, 10,500. So we need the firing cost to be as high as 10,500, and it forces you to say, okay, I won't fire you. I'm not going to fire anybody. It's better to just keep the guy around. He just gets to have, he just smokes all day long. Right? So it's like, because at that period on, whether it's month 6 on or month 5 or so, we're not using them anymore, right? They're not we don't need to produce them. So, but I say, yeah, man. Are there people? It costs too much to fire the guy. It's like, just keep them around. We have a few professors. I was talking to somebody, not in our Bauer, but over in the other colleges, and they're just afraid that he'll just sue us and he'll just run us. So it's better to just pay the guy his low minimum wage and just keep him around. And we don't even let him teach because he's terrible. The guy's like senile. I go, well, jeez. She goes, yeah, but I mean, there's only a few of them, and so that's okay. I feel like maybe 1 or 2 in smoke. And that happens in every company. So, you just keep them out of the way. Okay, next. I shouldn't be airing dirty laundry, but I have to tell the truth. Okay, now we go on. Oh, and what advertising effectiveness? Now, currently we're paying $10. When would it not be okay to maximize the advertising? Because right now we're spending all $50,000 that we have. So that means that what happens if we drop to $10 or increase it, right? Why don't we increase it to $10 and say now for every additional sale, it should be more than $10. It's not as good. Let's say that costs. So I think I'll do, let's do it. So essentially, and again, we're interested in such that we, okay. All right, so we're going to go, let's go back to the thing. We go to here. And where's the advertising, right? So here it is. So this is how much we spent, right? So again, what we're interested in, what point where the advertising, it costs me more, we don't use it all. So again, we're going to want it somewhere in any of those months. So we don't sum now, right? We just want to see a number. So right, you know, that's lower than 50,000. So what we're going to do is to equal and type min, right? And I'm just going to min those cells, right? So as soon as I see something drop under 50,000, depending on the what if, so I'm selecting B32 through G32, so I'm getting all those cells, right, that we decided. I'm going to do the min equal return. So right now it's still 50,000, because the minimum of all those numbers is still 50,000. So what are we going to do again? We're going to go ahead and change the advertising cost. Right now is $10. We're going to keep increase it and see at what point suddenly we actually don't spend all $50,000 for advertising, right? Because it's getting too costly. So we'll do a solver table again. One-way table. This time, the input cell is B13. And now, we started at $10, so I'm going to say 10. And randomly, I'll say, let's increase it to 80. I think somewhere between $10 and 80, they ought to drop, stop maxing. And let's increment it by 5. And my output cell this time is the min one I did, right here. So in my case, I placed it in that cell. I have J32. So you ready to run? And we'll see what happens. So that'll be interesting. I should have asked. Now this is kind of interesting too. Check out. Is this what I got? No, it looks like that. So at 35,000, one of them we lowered our, one of the months we lowered our, at least one of the months we lowered it. And you can see that at $60, one of the months we decided to lower it down to only 12,000 advertising budget. Okay. Now I wonder, just out of curiosity, I'm going to run this, you guys. You don't worry about it. I'm going to do. Let me come back here. You don't have to do it. I'm going to do this first. I'm going to go to solver. I'm going to go to the option. I'm going to put 0. So I want the optimal integer solution. And I'm going to solve that first. So that one's okay. It's still there. But now I'm going to run this out. So this one's still the same answer. But now I'm going to run solver table with the same setup that we have. So everything's still there. I'm going to do it again. It changes. Now you see your solution, you guys earlier, but you see how it changes? So why again? Because I set the optimality to 0, so it looked, even with the integer constraints, but it went to every possible integer instead of say good enough. 1% is you're within 1%, but you could have been better. So by putting it at 0, we now saw the shift. Okay. So if you're curious about when you do it and you run solver, just make sure you know that you put 0, that means no messing around. Got to try all cop. But you know, depending on models, it could run forever too, right? So this one's a simpler model, so you can see what's happening. Okay. Okay. Yeah, I was wondering, how come, what's going on here? And the last one, yeah, well, last one, might as well do it. How much would you be willing to pay for a 1% increase in worker productivity? How much would you be willing to pay for each 1% increase in worker productivity? So how do we do that? And what does that mean? How would you? Okay, let's call it quits. I'm too tired. So it's already 3:45. So I actually know what to do, but you got to think about it. So if you already have the spreadsheet the way you have it, try to redo the spreadsheet. Try to solve this. We'll work on it on Thursday. So you want a hint? So the current worker productivity is 600. So you're going to choose something where you, well, it's a tricky thing. I'll show you. So you have to change. You mean right at the start? Yeah. So you never got it.